Welcome back, geometry students. For our notes today, we are going to be looking at IC2 in Class 2 Algebra Review, and we're actually going to be working on the back side of that page. So if you want to find that and then flip over to the back side where number 9 through 16 are located, these are all what we call quadratic equations. That means that they have some type of variable that has been squared, multiplied by itself. X times x is x squared. And so this is an algebra skill that's a little bit more complicated than the basic equations that we reviewed solving previously. This typically comes up in the last portion of an Algebra 1 class. So we want to make sure that you remember how to solve these equations as they're going to show up in our geometry problems throughout this school year. And then again, it'll be a tool that you'll use when you move on to Algebra 2 next year. So what we need to do when we deal with quadratic equations is pay attention to what else is in the equation. There's going to be some kind of x squared there, but we also need to see if there are any x values as well. So this equation doesn't have any other values that are just an x. Neither does equation number 10. All of the other values are just constant terms, numbers. Neither does equation number 11. But then when we get to 12, things start to get a little bit more interesting. So let's tackle 9, 10, and 11 first. Since these all just have an x squared term and no x to the first power terms, our goal is going to be to isolate that x squared term so that we can solve by square roots. That's going to be the easiest way to solve these. So we want to start by taking that positive 10 and moving it to the other side of the equation by subtracting on both sides. That leaves us with x squared on the left side equal to 9 on the right side. And then because that x squared has a coefficient of 1, we are ready to square root. If you square root 1, you just get 1. And if you square root x squared, you get x. So that's the way that we take care of eliminating that power of 2. If you square root on the left side of the equation, you want to remember to square root on the right side as well. The square root of 9, most people will say is 3. That's true. 3 plus 3 is 9. But negative 3 times negative 3 is also 9. So this is where when we're solving with square roots, we're going to need to remember that there are two potential answers, positive 3 and negative 3. So we'd have two answers for what x is equal to in that equation. Moving on to number 10, it's very similar. We just have an x squared term, no x to the first terms, but we want to make sure we're careful about these two constants and moving them to the other side of the equation in the appropriate order. We want to kind of reverse our order of operations. So we're going to move that plus 1 over to the other side first with subtraction. 3x squared then is equal to 9. We do need to get rid of this 3 before we square root because the square root of 3 is not a friendly value. So if we do that with division, 3 divided by 3 will give us that 1 we're looking for to just be x squared. And now we're set up like we were before to square root both sides. The square root of 1x squared is just x. The square root of 3 is not an integer value. If we type that into the calculator, it would give us a decimal value. So we're still going to include positive or negative, but we can just leave that square root of 3 as is. We might talk about simplifying square roots at some point in time. We definitely will when we get into second semester for sure. But for right now, plus or minus the square root of 3, positive square root 3 or negative square root 3 is good. One more of these, so let's see if anything different happens. We're looking at negative 2x squared plus 5 equals 11. So like before, we're going to get rid of that plus 5 first so that that x squared term is isolated. 11 minus 5 is 6. We're going to divide by that coefficient in front of the x squared, which leaves us with just x squared on the left, but negative 3 on the right. Now, when we take a square root, we have to think really carefully about what's happening. The square root of x squared is x because x times x is x squared. Can we multiply anything by itself and get a negative number? Not any real numbers. And so this is actually a situation where we don't have any real solutions. Later on in your math career, you'll learn about imaginary numbers, and those will actually pop up when we square root negative numbers, but since we haven't learned about those at this stage of the game, we're just going to say that there are no real solutions. Okay, moving on to number 12 and 13, we're setting you up for situations that are going to have more than just an x squared term. If we were to distribute this 3x squared to these two parts, don't write this down on your paper, but what would happen is we would end up with a 15x squared from that first multiplication, and then 3x times positive 18 would be plus 54, I think it is, x's. And so what happens is we have an x squared term, that's what makes it quadratic, but we also have an x to the first term. And so these are more complicated to solve because we can't just square root part of it. We don't want to square root this term because we don't know the square root of x. And so this is actually going to take us down a dead end. We won't be able to solve if we distribute that 3x to both of those terms. Instead, what we're going to use is something from, hopefully that you remember from last year, called the zero product property. And that zero product property tells us that when two things multiply together to be zero, it absolutely must be true that either the first one equals zero or the second part of the product equals zero or both. And so what we're looking for is a multiplication problem equal to zero in order to solve these. Right here is where the multiplication happens, right where that parentheses pops up. So we can set 3x equal to 0 to figure out when that's true, and then we can set 5x plus 18 equal to 0 to figure out when that part of the product would be equal to 0. These are just equations like we practiced solving previously, so we can solve these individually. 0 divided by 3 is 0, so one potential answer is that x could equal 0 to make this equation true. In the other equation, we would subtract 18 from both sides, and we would get 5x equals negative 18. Divide both sides by 5. You could report that as a decimal if you like, but I'm just going to leave it as an improper fraction. I would reduce that if I could, but there are no common factors between negative 18 and 5. So we're back to having two potential answers, but they're not opposites like they were for the first two problems that we did. They're unique and different because these two factors are unique and different. Different values of x make them equal to 0. Number 13 is set up the same way. There's multiplication right here. These two binomials are multiplied together to equal 0, so we're set up for our zero product property. We can imagine then that we are looking for values that make either x plus 3 equal to 0 or 2x minus 7 equal to 0. Do some quick solving on those, and either x is equal to negative 3 in the case of that first part of the problem, or if we add 7 to both sides and then divide by 2, x is equal to 7 halves. Again, you could report that as decimal if you wanted to, but I'm just going to leave it as this reduced improper fraction. Okay, so we have solved by square roots in two cases. We tried to solve in a third case, but we didn't end up with a real solution since we were trying to square root a negative number. And then we've set up two zero product property problems to remind you of how to solve those. The last three problems we're going to try to solve with zero product property because we have quadratic terms and x to the first term, so we're not able to square root. But the difference is, if you look at this is not set up as a product yet. And so we need to go through a process called factoring to make sure that we can set it up as a product so that we can solve those two individual parts and figure out when this equation will be equal to 0. Now, the good thing is there are a lot of different ways to factor. The bad thing is there's a lot of different ways to factor. So depending on what algebra teacher you had last year, you may remember or you may have been taught a different way of factoring. So I'm going to run through a couple of different strategies. But if none of these are ringing a bell, please make sure that you reach out to your teacher so that we can try to figure out which method you learned when you went through factoring last year. Okay, this is a quadratic in the form of ax squared plus bx plus c. So you might hear your teachers talk about what values a, b, and c have when you're talking about quadratics. For this particular equation, A is equal to 1, B is equal to -5, and C is equal to -66. And so what we need to do is we need to look for whether those have anything in common first, called a greatest common factor, or GCF for short. Is there anything that 1x squared, -5x, and -66 could all three be divided by, basically, without creating fractions or decimals? And the answer in this case is no. We can only divide this by x and 1. Dividing this by 1 doesn't change anything. We could divide this by x, but we can't divide 66 by x. So there are no greatest common factors for this particular problem. So what we're going to end up doing is we're going to end up setting up two binomials like we had in number 13. We just need to make sure that if those binomials are multiplied together, they're going to create this trinomial, 1x squared minus 5x minus 66. And the way that we do that is by thinking about numbers that will create certain combinations. And so what we look for is something that will multiply to be whatever product A and C make. So if I take 1, that's the A value, and C, -66, and I multiply them together, -66 is the result. So basically what happens is I'm looking for two things that are going to multiply together to be -66. Okay, that's a multiplication symbol. I was trying not to use an X to keep it from being confusing. But at the same time, they also need to add together to be B. So we need to have -5 sitting here as an addition problem. So we can't just make one of these things true. We have to make both of these things true. Now, some of your teachers probably didn't write it this way. They might have put it in what they called a magic X. So they'd have multiplication to -66 and addition to -5. Some of your teachers might have made a little factor table with -66 up here and then just kept in mind that these numbers need to add to be -5 when you find them. So there are all kinds of different ways to think about what we're doing. The way that you show this work is not as important as being able to track down those factors that will work. And so if we start thinking about -66, I'm going to use this T-chart to start with. 1 and 66 would multiply to be +66. So if I imagine one of these being negative, I'll just make this one negative, they now add to be 65. Well, that doesn't work because I don't want them to add to be 65. So I go to the next factor pair, 2 and 33. Again, one of these is going to be negative, so I'm just going to make it that one for the sake of argument. Those now add up to be 31. Or if I made the -33, they'd be -31. Well, that still doesn't work because my goal is -5. So I just keep going and I keep looking for a pair of factors that will work. If I divide this by 4, I get decimals, so I can skip that. Same thing with 5. So I'm up to 6. So -6 and +11 would add to be +5. Well, that's not right because I need -5, but that just means I need to switch my signs. So if I make the 6 positive and the 11 negative, it works. So if I take 6 and -11, they multiply to be -66, but 6 plus -11 add to be -5. Or if you're this magic X person, you would write those as the sides of your factors. And so what that means is we've found the values that are going to live inside these binomial parentheses. The first part of the parentheses is going to come from this 1x squared term. So we're going to put a 1x in both of these slots from 1x squared. And then our +6 plus 6 and -11 minus 11 are going to take up the other two slots. Equals 0, just tags along. And then what we want to look for is we want to make sure this doesn't have any greatest common factors. Because we didn't have any at the beginning, we shouldn't have any in our factors. So 1x and 6, they don't have anything in common. 1x and -11, they don't have anything in common. So if I were to multiply this all back out, distribute everything, or some of your teachers might have called it FOIL, I will get back to x squared. I'll have -11x plus 6x, which is -5x, and then +6 times -11 is -66. So that means I have factored, so I'm ready to split this and go ahead and use my zero product property to find my solutions for x. Subtracting 6 from both sides gives me x equals negative 6, and adding 11 to both sides gives me x equals 11. Okay? These last two problems are very similar, but as you'll notice, they're not equal to 0 right now. And in order for the zero product property to work, our equation must be multiplication, a product, and it must be equal to 0. So my first order of business is to make that happen if it's not set up in that way. And I want to try to keep my x squared term positive. So I'm going to leave the x squared plus 9x alone. I'm going to subtract 22 from both sides to make that right side equal to 0. X squared plus 9x minus 22 is now equal to 0. We write that in descending order, and then we go through our thought process. Our goal is to find something, remember, that equals or that multiplies to be a times c, so 1 times negative 22. I need to find some numbers that multiply to be that. And then my b term is positive 9, so the numbers I find need to add to be positive 9. So if we start thinking through the factors of 22, we could think about 1 and 22, but if one of those was negative, they would add to be 21. 2 and 11, one of those negative, hey, that's it. That adds up to be positive 9. So my factors are negative 2 and positive 11, which means my binomials, I have a 1x squared, so 1x and 1x. You don't have to write the 1 if you don't want to, but I'm just trying to be clear about what's happening. And then negative 2 minus 2, positive 11 plus 11. Do a quick check for greatest common factors. 1x and negative 2 don't share anything in common. 1x and 11 don't share anything in common. So we should be all set up, ready to go. Set that first binomial equal to 0, set that second binomial equal to 0, and we end up with x equal to positive 2, or subtract 11 from both sides, x equal to negative 11. Last but not least, we've got number 16 here. Remember, try to keep that x squared term positive. So in this case, we're actually subtracting a negative 12x to make that happen. And our 0 is over here on the left. Keep this in what we call descending order. So x squared has the largest exponent, it comes first. Then we've got negative 12x, because that's the first power, and then we have our constant term 36. So one more time, our a value is still 1, so a times c is 36. That's our goal with multiplication, remember. And then our b term is negative 12, so that's our goal with addition. So if we start thinking about factors of 36, if they're going to multiply to be positive, they need to have matching signs. So either both positive numbers or both negative numbers. Since we're trying to add to be a negative 12, we know they need to both be negative. So negative 1 and negative 36 would be the first factor pair. Those won't work. They add up to be negative 37. Negative 2 and negative 18 add to be negative 20, so not quite. Negative 3 and negative 12 add to be negative 15, so that's not going to work. Negative 4 and negative 9 add up to be negative 13, so that's close, but not quite. If we look at negative 5, that won't work. Negative 6, I ran out of room, so I'm going to a second column over here. Negative 6 and negative 6, ding, ding, ding. Those multiply to be negative, or positive 36, but add up to be negative 12. So our factors, again, are going to be binomials. 1x squared means we're going to start with 1x, and then negative 6, so minus 6, and negative 6, so minus 6. 1x and negative 6 don't have anything in common, so no greatest common factors for us to worry about. And in this case, we end up with an interesting situation where these equations are identical. So when we solve by adding 6 to both sides, we get the same answer twice. It's called a double root, but really it just means that there's only a single answer. X is equal to 6. All right, we'll keep working on that algebra skill, but if you feel very overwhelmed about quadratics, that would be a great opportunity for either before school early session or RTI to get some more support remembering that skill from last year. See you in class.